Okay, so this question is design linked list. So it's actually pretty straightforward, but there are a lot of methods you need to implement. So let's look at the introduction. So what do you have? You have get. So you basically is get a value based on the index. So it's actually straightforward. If the index doesn't in a linked list, then we can just remove, right? Right. So next one is add head, and then add head, and then you pass in the value. So if imagine this is a head, and then this is the rest of the value in the linked list. So you are going to say, oh, I have a new value. I'm going to, become the head, and I'm going to point at the old head. So it's going to be this, right? So this is how you do it. Another one is add a tail. So this is head, this is tail. So I have another one, this node, that I want to become the last in the linked list. So again, we create one. So I'm going to say tail, and you want to point your, the old tail into the new tail, and then you want to delete the tail. I mean, it's not deleting. It's actually updating your tail to the last value. All right, so this is okay, and then this is add an index. So we can basically use this function to help to create add a head, add a tail, and delete an index is actually straightforward. So imagine, you want to delete the middle one, right? So you want to traverse until here, and then you want to point your next to the next or next. So this will become, right? So we're still not, deleting the actual node. We are actually making my next pointer to the next or next. So this is the idea. All right. So let's back to the code. So yeah, this pointers. All right. So normally what we have to do is we can create a node. So how do we create? It's going to be this. So class list node, and then what do we have for this? We have value, and we also need to know what is the next value for the list node, right? So the default construction is this. So val can be represent what? The passing value, right? So in val. And then next we'll just initialize to list node, something like this. Alright, so once we have list created, we can use list to actually, starting our linked list, right? So I'm going to say list node head, and also I need to know the size. So head will become what? New list node 0. It's going to be dummy head, right? Dummy head. Right, size is initialized to 0, right? So the get is actually straightforward. If the index value is less than 0, which is not possible, right? So the index value is greater or equal than the size, which we didn't even assign. Then we want to return 81, right? This is straightforward. All right, now we want to make sure we're traversing the linked list node and then the linked list. Then we want to make sure we are getting the right value. So let's do this. So I have a dummy head, so I'm represent head. And let me just keep going. Alright, so let's represent index 0, index 1, index 2, index 3. Imagine you want to get index 2. Right, get index 2, so you want to return this value, right? So what you need to do is you want to traverse from I equal to 0, right? And then traverse here, and then since you are here and you want to traverse here, so you want to actually hit the index 2. So you want to hit the index 2, and you want to return the list node value. So before that, since we are actually traversing, we don't want to rearrange our head. So I'm going to just say no, assign to head, and I'm traversing based on the no equal to no.next, and you want to say return no.value. Alright, so add a head, add a tail, and you pass in the val, right? So we can actually use this function, and then what is the head index? It's going to be represented 0, right? Alright, what is the value that we need to pass in? It's going to be val, right? Cool. So how about the add a tail? We have the size is represent the last index. Again, it's going to be add an index, size, and value. So yeah, basically this is actually, you know, pretty straightforward. So now we want to look at this, right? So add an index is actually, you know, basically we add based on the index that we're given, right? So if the index is greater than the size, we don't want to care about it. But however, we using add a tail and add an index, these two methods. So I mean it's fine, but think about this. They can call add an index at any way, right? So we want to make sure the index is actually less than or equal to the size. So if now I want to return. Alright, so now we want to know there's a list node add into the linked list, right? So the size is going to be incremented by 1, no matter what. And then again, I need to traverse list node, now equal to head. And then I want to just traverse until the one before, right? So it's going to be no equal to no.next. So you don't want to actually hit the index because you want to do this. So this is 2, index 2, let me just keep going. Alright, and this is in the value 10. Okay, so 0, 1, 2, right? So you want to actually add a value at index 2, and index 2 will point at the previous index 2 value. So let 0, 1, 2, 3, 4, 5, right? You want to do this behavior. Right, so list node, new node will become new list node and creating the val, right? And then new node.next is going to be the node.next, right? And then node.next is going to be new node. Alright, if you don't understand this part, draw on the paper, and then you will actually understand. And actually, new node is what? The new index 2 that point at the previous one, and then the previous one. The previous one dot next is point at the index 2. So let me just draw it again. All right. So this is the original one, right? 0, 1, 2, 3, 4. Alright, I'm passing the 2 and value 10, right? So this is what? Index 2, be honest. 0, 1, 2, 3, 4, 5, right? This is what we want to make, right? But initially, it's like this, right? Right. So we are traversing 0 to 1, right? 0, 1, so now it's going to be here, right? Creating a new node right here. New node.next equal to node.next, right? So node.next is this one, so new node.next equal to this one. And then node.next equal to new node, so this one. So you actually replacing this. Alright, so this is the idea. Alright, delete an index. Again, you don't want to delete something that is not in the linked list. So if the index is less than 0, or index is greater or equal than the last value size, you want to return. Alright, so you are actually deleting, so the size is going to be decremented by 1. And then if the index is actually equal to 0, the head just, change to the next one, right? And I want to return. Alright, so again, you want to delete, so yeah, it would be better to draw a little bit. So this, I imagine you want to do this one. So what you need to do is you want to traverse until here, right? So it's going to be from 0 to index -1, right? And then you want to make sure the next pointer is going to point at next on next. Alright, so this no equal to new, no, I point ahead and then traverse, right? So for in I equal to 0, I less than index, I plus plus, and then no equal to no.next. Okay, so you want to move your pointer to index -1, and this is how you do it. And then you say no.next is equal to no.next on next, right? Okay, so this will be the solution. Where's the problem? Right here? No, line A. Line A. Okay. Yeah. So this will be the problem. We don't need to initialize. It will actually default by no. Cool. All right. Let's talk about the time and space. Again, let's know time, space is going to be constant. This is space, right? For every single function, I'm going to just have my answer. So my linked list constructor is actually constant for space and time. How about the get? Space is going to be constant, time is going to be all of index based on your index. So the worst case is going to be all of n, right? You can traverse until the last one. So time is all of n, space is constant, and at head, at tail based on the index, right? So let's look at this. Space is actually constant, right? You only create 2 values, but you are traversing, so the time is all of n, space is constant, and you apply to these two. How about the index? The space is constant. Alright, space is constant, time is actually all of n if index is the last value, right? And even though if the index is last value, right, you can actually point at next on next, which is going to be represent no, like a trash, right? Trash is no. Everything if you didn't define is no, right? So it doesn't matter if it's the last value, then you point at next on next. Alright, so this will be the solution. So if you have questions, leave a comment, and I'll see you next time. Bye.